if we want to determine the equation of a quadratic function given its roots, okay, I'm going to give you the general format for this. The general format is, let's say, let A, that's no good. Let A be one root. Let B be another root. So the general equation would look like this for this type of thing. The general equation is f at x equals a. Oh, I better call this something else because we need different symbols. I'm going to call it b and c. So it'll be x minus b and x minus c. So that's sort of your general overall format for this type of thing, okay? I'm just trying to keep it simple, so given the shortened period. Find the equation of a quadratic function that has the given x-intercepts and contains the given point. Express each function in factor form. Graph each function to check. Okay, let's do it out here. Since x equals -2 and x equals 4, right? They give you the two roots. So you know this. Since we know these are x-intercepts, we know, we know x plus 2 and x minus 4 are factors of your quadratic function, are factors. Okay? Just cross that out, cross that out. So if we were to set this up into this equation, we have f at x equals x plus 2 times x minus 4. So far, so good? Oh, with a in front. So what do we use the given point for? We're going to sub in -1 comma -10 to find a. So let's do that. -10 is our y value, or f of x value. -10 equals a. Now x is -1 plus 2 and x is -1 minus 4. So -10 equals a times 1 times -5. So 1 times -5 is -5. So a equals 2. Therefore, the function is f at x equals 2 times x plus 2, x minus 4. That's our function. So let's graph it. Let's just graph it. X minus 2 and x equals 4. So we know our axis of symmetry occurs at axis of symmetry. X equals -2 plus 4 divided by 2. That is the axis of symmetry is x equals 1. We just have to find out where that vertex is. They gave us a point, -1, -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know another point would be, if that point is 2 over from the axis of symmetry, we know that we must have another point over here from the axis of symmetry. Right? It's symmetrical. We just have to calculate the vertex. The vertex happens at x equals 1. So, let's see. F at 1 is equal to 2 times 1 plus 2 times 1 minus 4. It's going to be 2 times 3 times minus 3, and that equals -18. So this is going to be, it doesn't fit, dagnabbit. 1, 2, 3, 4, 5, 6. I guess we'll just have to go below. 7, 8. Dagnabbit, eh? Just estimate that vertex down there. So now we can draw our graph. And this was -10, and this is -18. Vertex is 1, -18. It's not too bad, right? Can I explain anything better? Anything at all? Let's try one more. Ooh. X-intercepts are radical expressions on number 2. Nobody have questions? Okay. So we know x-intercepts are this. X equals -2 plus √7, or x equals -2 minus √7. So we know that, we're given that. So we know our factors are, why don't we just put it in function form here? Because A is going to be x plus 2 minus √7. And this is going to be x plus 2 plus √7. Let's simplify this a little bit. We're going to have to do 9 multiplications here. X times x is x squared. X times 2 is 2x. X times √7 is plus √7x. Plus 2x plus 4 plus 2 √7. This is going to be minus √7x minus 2 √7, and that's going to be -7. Should I go do that? Would you like me to do that again? Right? X times x, x squared. X times, that's 2x. √7x. And 2 times everything. 2x plus 4 plus 2 √7. Then minus √7x minus 2 √7. There. Okay. F at x equals a x squared. That's 2x plus 2x is 4x. And that's plus √7x minus √7x. 2 √7 minus 2 √7. So we got 4 minus 7 is -3. Now we're going to find A. We're going to sub in 1, 2 to find A. Alright, so we'll do that. 2 equals A times 1 squared plus 4 times 1 minus 3. 2 equals a. So 1 plus 4 is 5, minus 3 is 2. So a equals 1. Our equation is f at x equals x squared plus 4x minus 3. Well, it's kind of hard to graph something with the square root in it. So let's just see if we can just do something else here. Let's find our vertex. Oh, axis of symmetry. It's going to be x equals minus 2 plus root 7. We're going to have to add them together, right? Minus 2 minus root 7 all over 2. So the axis of symmetry is, like I'm adding up the two roots. There's two roots here, right? Here and here. We add them up and divide by 2. So it's going to be negative 4 divided by 2, and that equals minus 2. So our axis of symmetry is there. One of our points is 1, 2. There's one point over here, right? If this is 1, 2, 3 over, then this one must be 1, 2. I'm using the properties of symmetry to get 2 points. If I get my vertex, that will be enough, right? So to find the vertex occurs at x equals negative 2. So let's sub in f of negative 2 equals, I'm subbing it in here, is going to be negative 2 squared plus 4 times negative 2 minus 3. So that's 4 minus 8 minus 3. That equals minus 7. So my vertex is negative 2 minus 7. 1, 2, 3, 4, 5, 6, 7. And that's enough to sketch our graph. It doesn't have to be accurate. Fair enough? So that's how you find an equation of a function given two roots and a point. Let's just do a couple of examples and then we'll be done. Find the quadratic function that has only one x-intercept, and so that means there's two equal real roots, right? They give you this x-intercept, x equals 5. What, you know, if it's two equal roots, there's two factors, but they're the same, x minus 5 and x minus 5. So f at x equals a times x minus 5 squared. We can sub in 4, 3 to find a. So 3 equals a times 4 minus 5 squared. That's negative 1 squared is 1. So a equals 3. The function is f at x equals 3 times x minus 5 squared. Now your test question might say express that in standard form. This is factored form. Standard form, you have to multiply it out. So standard form would look like this. This is standard form. Like, is this okay? You guys, some of you guys look tired today. Yeah? Is that what happens when you get to sleep in on a late start? You stay up later?
Yeah, or you expect to sleep in more, so when you wake up, you're tired.
Yeah. It happens. Just wait till you get old. Then you're tired 24/7. Okay. A football is kicked off the ground. After traveling a horizontal distance of 24 meters, it just passes over a tree that's 3 meters tall before hitting the ground. My goodness gracious. 28 meters from where the ball is kicked. So the easiest way is maybe to put 14 meters on this side and 14 meters on that side. For a total of 28 meters. So you have this ball traveling 28 meters. Woo! Just like that. We'll call this X, we'll call this Y. Assume that, oh, but plus they tell you, consider the ground to be the x-axis. Assume the vertex lies on the y-axis, so you know your vertex is there. So you know it has to travel half the distance here and half the distance here. Determine the equation. Okay. So I guess we'll have two x-intercepts, a negative 14 and 14, but they're also telling you it passes over a tree that is 3 meters tall. This is 3, right? And it's at 24 meters. So 24, so this is 10. Can you see that this point is 10 comma 3? Right? Because it travels 14 or plus 10 is 24 meters. It passes a tree that's 3 meters tall. So that point. So we have two x-intercepts and we have a point. So we can find the equation. X equals negative 14 and x equals 14. These are the roots. The factors are x plus 14 and x minus 14. So our equation, we can plug it into here. Finding A, we have 3 equals A times 10 plus 14, 10 minus 14. 3 equals A times 24 times negative 4. 3 equals A, that's negative 4 times 4 is 16, carry 1, 4 times 2 is 8, that's 96. A equals negative 3 over 96. A equals negative 1 over 3, 2. So f at x equals negative 1 over 32, x plus 14, x minus 14. So that's factored form. If they want it in standard form, just in case, you never know, x squared minus 14 times 14. I got a 4 times 4 is 16, 56. It's 196. So this would be negative 1 over 32 x squared minus 196 over 32. I guess we can bring that down to lowest terms. I guess 4 goes into that, right? 4 goes into that 4 times. 4 goes into 36 9 times over 8. This is your standard form. Okay? Sorry? Only if the question asks you to. Okay? But this question didn't ask me, but I'm just emphasizing that if they wanted to, you know how to do it, right?